Right, so this is the last one on your quiz. What was it, number 6?
Yeah.
On your quiz. An unknown acceleration, you integrate to get a velocity equation. Let's integrate again to get a position equation. How do you integrate a times t? T squared over 2? With an a sitting there.
Yep.
How do you integrate v naught? V naught t. And then it spits out an s naught. Now, if I was you, maybe, I don't know how clear the problem was, but this guy was standing here, and he was ready to kind of, there's his cake. He was standing here, he was going to run and try to take off and fly. So, but I would say he starts at here with a v naught of 0 and an s naught of 0. Wouldn't you? I mean, let's just call this, we'll call this place 0. And his v naught was 0 because he was just standing there. All right, so that makes this pretty easy. That makes that makes my velocity equation just turn into this, and it makes my distance equation turn into, hey, if that's 0 and that's 0, my distance equation is just a over 2 t squared. You guys with me?
Yeah.
All right, so here we go. What were the 2 requirements? In order to fly, Superman has to reach this place, and what has to happen when he reaches the end of this thing? It said he had to have a speed of 200 feet per second. So he has to reach that speed. He's running. He's going to run this way. He has to reach that speed before he can take off. What else does he have to do? Oh, how long is his runway? 80 feet. So there's 2 things that has to happen. When he reaches this 80 feet, he better be going this speed. When he reaches 80 feet, he better be going this speed. Now, do you have any equations you could plug that into?
Yeah.
Yeah. So, right? So when this is an 80, I want this to be a 200. That's what I'm saying?
Right.
And he'll be able to fly. And now what I want to do is find the A that makes that happen. I'm looking for the acceleration that makes that happen. I can do it now. It's so easy now. I mean, again, when I say that, you stare at me funny. I mean, I'm worried you don't know how to. I mean, when I have 2 equations with 2 variables, I'm so happy. I know I can finish. It's just a matter of doing it, you know. But I see the end, you know. I see the 2 equations, 2 variables. I can usually substitute and solve. So, I mean, that's the key to the whole problem. And then the rest of this, a robot can do. But a robot can't. The human part of you has to read and think and set this up, kind of. But the robot part of you can do this. You want me to finish?
200 over t equals a.
However, yeah, you can either solve for t or solve for a and substitute over there. Either way, I think I'll solve for t. If I solve for t, I get 200 over a. And then I think I'll substitute that in for t. Is that okay? Now, I got to fight through some algebra here, but this is a over 2, and then this is something squared. What is it squared?
200 over a.
200 over a squared.
Yeah.
And this is not too bad. That's an a, that's a 40,000, I think. When you square that.
Yeah.
This is a 2, and this is an a squared. If I do a little canceling, the a cancels with one of those a's. This 2 makes this a 20,000 over a. You following me? I mean, I'm doing algebra. I like algebra. I do it pretty well. So I'm showing you how to do it. And then I would multiply by a and divide by 80. So a would be that 20,000 divided by 80. I mean, what's funny is, I don't know. It's 250, is that the answer?
Yeah.
I mean, it's a good problem. It was in the book. It was in 5.1. It was one of those problems in the book. But in the book, it was an airplane going off a runway.
Yeah.
But you know, maybe you should keep this in mind. I mean, I don't know. We've been doing this a long semester now, but I don't know. The problems I put on tests are usually not that difficult. But I mean, maybe the difficult part is the reading and the understanding and because the math, I mean, isn't all. I mean, it's usually the way my problems are. They're kind of interesting. Figure them out and set them up, but then they're not that hard. But you got to know what you're doing. I don't know. Like this one wasn't too hard either. But when you read, I know, when students read velocity and acceleration, when they read those problems, their brain might freeze up a little, or they're just not used to practicing it. I don't know. What else on that quiz? You know, this disturbed me. What was it, number 2? Number 2, you see, because we spent the day before the quiz, we spent the day kind of talking about how you should bust this up. Was that the problem?
Yeah.
Yeah. And see, a lot of you didn't catch the concept. I mean, listen, these guys both need U substitution, but rather than do it, you can't do it as one problem. You don't do this as one problem. So I tried to hint on a lot of your papers, you do it as 2 separate integrals. So you got this integral to do, and you got this integral to do. I mean, I don't know, you needed, I don't know. That's how you do it. I mean, that's an important concept of integration. You're allowed to integrate separate terms. And then it helps because these 2 problems need 2 different U substitutions. You need to let U equal 4x, and the result is it spits out a 1/4. And if I understand that, I'm done.
Yeah, that's where I got it wrong. I didn't put 1/4. How did it spit out 1/4? I thought it spit out.
Well, you might be you do U substitution is how it spits out. You let U equal 4x. Du is a 4 dx. I like to divide by 4 and make it 1/4 du equals dx. Then I replace all this. See, U substitution is a replacement game. So this integral turns into it's going to be a new integral. Instead of having x's, it's going to have u's. And what's it going to look like? Well, let's see. It's all dictated right here. Let's see. That's going to be e to the u, isn't it? I mean, that's my u. And then what's my dx? Oh, my dx is a 1/4 du. So I'll put the 1/4 out here, and then there's my du. So this problem, through U substitution, turns into this problem. And lately, and there's all the steps, and that's the explanation for it. But lately, I've been getting a little sloppy with my explanation. I feel like maybe we're getting good at this. And so I've been just sort of saying, dude, I know what this is. It's e to the 4x, but it spits out a 1/4. But if you don't know why it spits out a 1/4, then you better know why. You should know why it spits out a 1/4. So I just took some time to explain it to you. It'd be very cool if you understood this. It's important to understand the U substitution process and why it spits out a 1/4. But now, you're integrating an e to the u, which is e to the u. So you're done. And it has a 1/4 in front of it. So same on this. And so maybe I won't write all this down, but you're letting u equal 2x, and du is going to be a 2 dx, and the result is it's going to spit out a 1/2. So you're doing a little u substitution on this, and on this one it's a separate u substitution though. So you can't really join them together. That's why it's important to do 2 separate integrals. Anyway, he's going to spit out a 1/2, and so it's going to be 1/2 sine 2x. Some of you were changing the sign. What is the integral of cosine? Sine. So we don't change this. We're not changing this sign, right?
that negative, is that?
It was
from
here.
that- It was here, so we just bring it down.
It was, yeah.
Okay.
I mean, when I decided to bust this into two integrals, they had a negative sign in between them, I guess, right?
Or you could spit out a negative 9.
Oh, number 3 was.
3 was good.
That's
3 was good. 3 was the one where you had to have that extra x. I tried to make it easy. What is it? Was it this?
It was 3x.
Oh yeah, there was a 3 there. Yeah, thank you. Thank you. Yeah. Yeah, I better help you with this, because I kind of quit helping a bunch of people. At some point I decided I'd probably go over this quiz today. So I quit writing all the answers. You know what I mean? As I'm grading it, I like to help you, but everybody was getting it wrong. I said I'll just help them all at once. So this was, I thought this was maybe the toughest one because it made you solve for x in terms of u, but it's not. I tried to make it kind of easy. I didn't make it too crazy. Look, I think you should let u equal x plus 1. The problem is du is just a dx. So when you replace this, the problem is there's an extra x right here. This extra x does not get replaced. This gets replaced. It's u to the 7th. What about this? Does it get replaced?
du.
It's du. But there's this extra x, and so but we've learned on these are the tougher versions of u substitution, I think. When there's an extra x hanging around, we have to figure out how to replace it. And so we go back to this declaration we made, and we said that u should be x plus 1. Now let's solve for x in terms of u. So what is x?
U minus 1.
Move the 1 over. X is u minus 1. Oh, so I can replace this x with a u minus 1. Yeah, that's what I can do. And that's what I need to do. I mean, so this gets replaced. This is u to the 7th. And then some people made it here and then couldn't finish. And that's kind of sad, but now maybe you know that you should distribute and then integrate. That's a phrase that's come up quite often. You distribute and then integrate. So you don't, it's multiplied, and so you don't know how to integrate a product. So you distribute and then integrate each term. So u to the 7th times this u is u to the 8th. U to the 7th times 1 is u to the 7th.
Right.
So it turns into this. And now you can integrate two separate little guys there. They're just nice little power rules. 1/9 u to the 9th, 1/8 u to the 8th, plus c. There's a 3 in front of all that. You with me? I mean, it started off with that little slight difficulty that, oh shit, there's an extra x. How am I going to deal with that? I got to go solve for u in terms of x and replace it. Once I replace it, then you have the difficulty of getting through this, but this is not. You distribute and you integrate. It's not difficult. By the way, to finish it, what do? 1/9
X plus 1.
Yeah. X plus 1 to the 9th. X plus 1 to the 8th. Right. Did anybody think about trying to FOIL it out to the 7th?
Oh my goodness.
Is that doable?
I mean,
You can, but
Oh my god. I didn't want to think about it.
we're just such
now let me just say something. Somebody tried, but I didn't give him any credit for it. Poor guy. Maybe I felt sorry for him, but it ain't the way to do it. I mean, technically, I don't know. It might have been right, but
if you did it, you got it right.
yeah. But I didn't want to check it. It was too much of a pain in the ass for me to check it. So I just marked it wrong.
But he should end up with that.
Well, no, he'd end up with this all foiled out.
Oh my God.
Right. If you take the time to FOIL that out. I mean, don't do it like that. Now, and to avoid you doing it like that, I tried to put a 7th on it. I mean, even if it was like squared, maybe you could do that, but I still wouldn't. I would do this. This is not bad. Bam, 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 bam. You know. And if it was u to the 5th, you know, I mean, anyway, I said, shit, they're going to try to FOIL it out. I better put 7 so nobody tries to FOIL it out. But now, I think in the future, maybe I'll put like
32.
Yeah, right, 32 on there. Then I know you won't try to FOIL it out.
There's no way.
What else?
You do 5.
5. 5. 1, 2, 3, 4, 5. 5. I know what 5 was. 5 was this.
6. 5.
All right, so this is a good problem, and I kind of alluded to it earlier today, but I didn't really do it. Hey, but one more time, you guys. So if I'm integrating a sine 2x, how do you integrate a sine 2x? Don't you do a little u substitution on the 2x? You have to do a little u substitution on the 2x. But what, can I do it in my head? What's the result of doing a u substitution? It spits out a 1/2, I think. So I end up with a 1/2, and then I probably the sine of u du. All right, so now I got to integrate the sine of u, and I think the integration of sine is negative cosine. So I get negative 1/2 cosine u. Anyway, I don't know. Can you integrate a sine 2x? And it spits out a 1/2. Well, so this is the same concept, but the number is not a 2x. It's a more complicated number, but I think the concept's the same. I think you should let u equal the pi x over 4. And the number in front of x here is pi over 4. And so the du is pi over 4 dx. Now when it's a 2, you move it over and you get a 1/2. So when it's a pi over 4, you move it over and you get a 4 over pi. Du is dx. So it's almost it's the same thing as that, but it's a little trickier with that pi over 4 number. But instead of a 2, it's a pi over 4. But I'm dealing with it, and here I go. When the 6 comes out, and I'm saying a 4 over pi comes out, and then I'm left with the sine of u du. Maybe I went too fast there for you, dude. The 6 comes out. That's a u. How do I replace the dx? I replace the dx with 4 over pi du. So there's the du, there's the 4 over pi. So everything gets replaced. It's not magic. These are your directions for replacing this stuff. And there you are. And now that you're there, you know how to integrate a sine u. Negative cosine u. So it's negative 24 over pi cosine of u. And I'm going to go ahead and put that in there. Pi x over 4. And then it has to be evaluated from 1 to 3. And this is where I was trying to get you to do it without decimalizing it, leaving it exact if you could. You want me to help you finish? Okay. I'll move over here. So you plug in the 3 and you get negative 24 over pi cosine of 3 pi over 4. I mean, it might help to write all this out. You can see what's happening. Watch. Minus negative 24 over pi cosine of 1 pi over 4. Is that how you do it, you guys? You plug in the 3 and you plug in the 1. You subtract them. And then I know my unit circle, and I know the cosine of 3 pi over 4. It's famous. It's the square root of 2 over 2. Oh, in quadrant 2, it's negative. So it's negative 24 over pi, and this is the negative square root of 2 over 2. That's what that is. This is plus 24 over pi, because of those negative signs. And this is the cosine of pi over 4. That's in quadrant 1. It's 45 degrees in quadrant 1. The answer is square root of 2 over 2. So this is a positive, and this is a positive. They'll add together. They're the same number. Let's see, there's a couple ways to think here, but I would cancel this 2, maybe call this 12. Square roots of 2 over pi. Is that okay with you? Canceling the 2. And then here's another, same thing. 12 square roots of 2 over pi. And so when you add them up, you have 24 square roots of 2 over pi, which is approximately 10.8, which is the area under that curve, whatever that curve is from 1 to 3. I think it's kind of like this. Anyway. I'm always looking for work. So.
If we would have like put a decimal, it would have just been like -1.
Right. So if I could see all your work and
like if we would have just got
like right here,
like,
usually
that concept, and then we would have just put it as a decimal, we would have got -1.
right. So right here is usually where people would not call it square root of 2 over 2. Instead, they would punch it in their calculator and get 0.707 or something right here.
Yeah.
Anyway, and so then that means your decimal, and then you end up with the 10.8, and everything was right except for that. I took off -1 on this quiz, on that problem. In the past.
It would always be like that though, or no?
Well, depends on the mood I'm in when I'm grading it. But I do try to teach students from time to time what the difference between exact and approximate is.
Like I understand that, but like okay, like off the top of your head, like you just like you're good with trig. Like I'm not good with trig, so like off the top of my head, I don't know that 3/4 pi is negative square root of 2 over 2. Like I don't know that, so like I would have just put it in a decimal.
Okay, right.
That's what I'm saying.
And it would have cost you a point.
Yeah. Okay.
So. Yes, ma'am.
So since there's a bonus question on the take home, does that mean you're going to grade it and it's worth how much?
Right. So the take home quiz is a bunch of questions, and I randomly grade 4. But then the bonus question is sort of separate. It'll be I'll grade it. Right. I won't. Right. It won't be a randomly selected. It'll get graded, and it'll be just bonus points. And I don't know how many points yet. At most 10. Maybe 8.
Oh, sweet.
Yeah, well, it's kind of a lot of work. I mean, it's, most of my problems are, I mean, it's kind of got, what's it got, part A, B, C, D? Yeah. I mean, right, so maybe I kind of call that 2 points each. Maybe it's 8 points, but maybe I call it 2.5 points. I don't know. Yeah.
Each grade's important.
Are they what? What you say?
Do you have your grade book updated?
No. With the no. I mean, I do in my office, but I didn't print it and bring it.
Okay.
So yeah.
Talk to me.
Sure. Right. I guess I usually print it and bring it when more stuff is happening, like a test. So every time there's a quiz that happens, I don't always print it and bring it. But after the Chapter 5 test, I'll probably print it out and bring it and let you see where you are at that moment. But it's always updated in my office. That's right. Every time I hand back something, it's in my system. It's updated in my office. Yeah. What else you guys want to do? All right. So what are we doing Monday morning? Right, and we might want to get here early. I mean, what we don't want to do, well, we don't want to be late because we got a little shorter amount of time. So you don't want to wander in 15 minutes late. That would be bad for you. That'd probably be bad for you. So let's start on time or early, 5-10 minutes early. If you're ready, I'm ready. I'll try to be ready. All right, thank you.
No, I didn't.